to find the roots of the equation y equals x to the fourth plus 2x cubed plus 5x squared plus 8x plus 4. And before we can find the roots, I want you to quickly think how many roots is it going to have and why. Hopefully you decided with 4, and the reason that there is going to be 4 roots is because if we were to factor this polynomial here, we'd get 4 terms. Think about if you have a quadratic or x squared. When you factor that, you're going to get 2 terms. Maybe they're the exact same term, but nonetheless you will get 2 terms, and that will give you 2 roots. So here we know we're going to have 4 roots, and let's go ahead and take a look at the graph, because if we want to find the roots, it's going to be very helpful if we can take a look at the graph. So if I pull up the graph of the function here, I notice that when I graph it, there's only one root that I can see. All right, it's at -1. And when I see that this root is at -1, I immediately realize, okay, well, are there any other roots out there? I'm curious. And it could be, right, potentially, that you might be thinking, okay, there's one root at -1, but why couldn't it be that my equation is just x plus 1 to the 4th power? Well, it can't be x plus 1 to the 4th power, because if I multiplied this all out, x plus 1 to the 4th, I would not end up with this right here. And it's pretty easy to see why that would not happen. If you want to check it out yourself, that's a good exercise for you to do, so pause the video and try it out. But if you have done this before, you'll know that when I multiply that out, I'm not going to get this right here. I'm not going to get that last coefficient. So what we're going to do now is going to go try and find some other roots. So knowing that -1 is a root, x equals -1 is a root, we can use this to help us find more roots. And I want you to think about why that is real quick. Hopefully you came across the fact that if this is a root, that means that x plus 1 is a factor. What does that mean? That means that I can write my polynomial as x plus 1 times some other polynomial. That's what it means. And so using my intuition with the division algorithm, if I divide my polynomial by one of the factors, in this case x plus 1, I should get another factor, and I will get another factor. So using this train of thought, we're going to go ahead, clear a little space up, and get to work here. So I have x to the 4th plus 2x cubed plus 5x squared plus 8x plus 4. Now look at this even farther out of the way. And we're going to divide by x plus 1, just like so. Alright, and so remember, in thinking about dividing a polynomial into another polynomial, what we're really looking for is a polynomial which, when I multiply by x plus 1, will give me my bigger polynomial back. Right? And so thinking about that, we need to think about, okay, what terms will I multiply x by to get x to the 4th, and then repeat, right? Go on from there. So x times x to the 3rd will give me x to the 4th. So now I multiply my x to the 3rd by both pieces. So I will get x to the 4th plus x to the 3rd. And then I want to subtract both from my original polynomial to see what I have left. So then I want to divide my x plus 1 into what I have left. My x to the 4th powers will cancel, and I'll end up with x cubed plus 5x squared plus 8x plus 4. Continuing on, x will go in x squared times, which will give me x cubed plus x squared. Continue. I'm going to subtract both pieces. Those will cancel, and I'll be left with 4x squared plus 8x plus 4. X plus 1 will go in 4x times, which will give me 4x squared plus 4x. Sorry, not plus 4. Forget that. I'll subtract both pieces again. My first terms will cancel, and I'll be left with 4x plus 4. And this, I can tell I'm on the right track because this will go in evenly. It will go in 4 times, and I'll get 4x plus 4, which of course, when I subtract, will cancel each other out. And so I'm left with my new polynomial here, x to the third plus x squared plus 4x plus 4. Okay? And at this point, I have a little bit of an issue. Right? I have a cubic polynomial here. I'm going to leave that there. I have a cubic polynomial. A cubic polynomial, and what I need to do is somehow factor it. Find some factors from it, because factoring is not going to be very fun. And at this point, we need to make a realization. We need to come back to our graph. And in looking at our graph, we need to realize that the function has an interesting characteristic when it hits -1. Instead of passing through the x-axis, notice how it bounces off the x-axis, which means that the multiplicity of that root has to be even. Alright, so when I'm writing my function, I need to have y equals x plus 1 to some power that's even. Now we thought about 4, and if you did that exercise of actually factoring that out, you saw that that couldn't be our function. So our only other option is that this is squared, meaning that there is 2x plus 1 terms, and then our other polynomial, which means that we can actually factor out another x plus 1 from my new polynomial. And in order to do that, we just have to divide our polynomial from our quotient by x plus 1 one more time. So I will let you go ahead and do that on your own. So pause the video and do that on your own. And when you come back, we'll discuss what it should look like. Alright, so hopefully in your factoring, you were able to come up with the correct polynomial that I've got left over. So when I divide by x plus 1 the first time, and then I divide by x plus 1 the second time, I'm going to end up getting x squared plus 4. And at this point, you are realizing something, hopefully, which is that I need to figure out what's going to make that particular factor 0. Right? Because I know 2 of the roots, right? I know this factor here gives me x will equal -1. That's one of the roots. In fact, it's 2 of the roots because it has multiplicity 2, right? There are really 2 of these factors. So now the question is, what makes this 0? In other words, x squared plus 4 equals 0. At this point, I want you to pause again, and I want you to go ahead and solve for that. Hopefully, after solving, either using the quadratic formula, because this is a quadratic function, or quadratic root, or just simply solving for x, you're going to find that x will equal plus or minus the square root of -4, which of course is plus or minus 2i. It is an imaginary root, or a complex root. And so what that means is that the 2 other factors, all right, if I were to factor this out, I would get two factors, and I would end up with y equals x plus 1 squared. And then one of my factors is going to be x plus 2i, and another factor is going to be x minus 2i. Why? Because if I'm going to plug in, for example, if I plug in negative 2i here, right, this will go to 0, and I will end up with 0, my entire function equaling 0. Likewise, if I plug in 2i here, I'm going to end up with 0 again. My function will go to 0. So now I have all four of the roots, right? My first root is x equals negative 1. Then I also have negative 1 again. This has multiplicity 2. And then I have a root at negative 2i and a root at positive 2i. And so there are my four roots.